In this video, we're going to move on from determining the empirical formula to determining the molecular formula of a compound. Now, the definition of molecular formula, it's the actual inventory of the elements in a compound. It tells you the number of each element in the compound. The molecular formula will be a whole number multiple of the empirical formula, but that whole number can be 1. Sometimes the empirical formula and the molecular formula are the same. What we then need to do is to compare the mass of the molecule or the molecular weight to the mass of the empirical formula or the empirical formula weight. So you set up a ratio with molecular weight in the numerator and empirical formula weight in the denominator. The denominator should never be greater than the numerator. It might be a few centigrams bigger, but they really shouldn't be markedly bigger. And there are 5 steps to take. The first, you need to determine the empirical formula. Then you need to calculate the empirical formula weight, determine the molecular weight, divide the molecular weight by the empirical formula weight, and then multiply the subscripts of the empirical formula by the value obtained in 4. So let's start with a non-chemistry example. Assume that I'm going to build something with blocks. I have red blocks, which weigh 1 gram. I have blue blocks, which weigh 3 grams. And I have orange blocks which weigh 5 grams. I take my blocks and I make a unit that looks like this. We're going to call that a basic building block. I've got 3 oranges, 2 blues, and 1 red. The mass of that building block is 22 grams. Now I can build anything I want, but I have to use the building block and I must use a complete building block. I cannot have a partial building block. Thus, anything that I build will have a mass that is a whole number multiple of 22 grams. If I know the mass of the object, I can divide it by 22. I'll know how many building blocks I need. So suppose I'm told to build a structure that has a mass of 66 grams. Well, 66 divided by 22 is 3 blocks. I need 3 of the building blocks. So I might get something like this, and notice I now have 9 oranges, 6 blues, and 3 reds, or each of the subscripts of the original building block were multiplied by 3. But you may notice that I could have built something that looked like this, something that looked like this, or even something that looked like this. All have 9 oranges, 6 blues, and 3 reds. This is an important distinction. The molecular formula gives you an inventory of each element in the molecule, but it doesn't tell you how they are put together. That is called the structural formula. So the molecular formula here is 9 oranges, 6 blues, 3 reds. I can put it together like this, or like this, or like this, or like this, and in actuality there are a whole lot of other combinations. So let's take this chemically. I've got C2H6O. It can be put together this way. The 2 carbons bonded together, the oxygen to one of the carbons, and then the 6 hydrogens as noted. But I could also build it this way. This is ethanol. This is dimethyl ether. These are called isomers. Isomers are things that have the same molecular formula, but a different structure. So they'll have the same molecular weight, but different physical and chemical properties. So now the best way to show how to determine the molecular formula, I believe, is to dive right in. So a compound is made up of aluminum, carbon, and oxygen, 16.97, 22.66, and 60.37% respectively. You're given the molecular weight of the compound is 318 grams per mole. What's the molecular formula? Just follow the steps. Determine the empirical formula, use the poem. So here we've gone percent to grams, grams to moles, divided by small and multiplied till whole. So the empirical formula is aluminum C3O6. On to step 2, determine the empirical formula weight. You do this the same way as you would figure out a molecular weight. I have 1 aluminum, I multiply that by 26.98. 3 carbons multiplied by 12.01. 6 oxygens by the 16 grams per mole. So my empirical formula weight is 159.01 gram. On to step 3, determine the molecular weight. Well, in this problem, it's easy. You're given the molecular weight of 318 grams per mole, so you put that there. Step 4, divide the molecular weight by the empirical formula weight. So 318 divided by 159.01 equals 1.9999. That's close enough to call it 2. So now you're going to multiply the subscripts by the value obtained in number 4. So 1 times 2, 3 times 2, and 6 times 2. And the molecular formula is aluminum 2, carbon 6, oxygen 12. So now there's one for you to do. You are given a compound that is composed of carbon, hydrogen, and chlorine. All the information you need is in the problem. Stop, figure it out, get your answer, come back, check it. Then, as always, I'll walk you through it. Go. And the correct answer is C6H12Cl2. How did we get that? We followed the steps. So we determined the empirical formula. We've got the percentage of carbon, we've got the percentage of hydrogen, but we're not given the percentage of chlorine directly. But we do know that 100% has to equal the percentage of carbon plus the percentage of hydrogen plus the percentage of chlorine. Plug in what we know, rearrange, and so the chlorine must be 45.73%. So now we can go and work off of the poem. We set things up, and we see that the empirical formula is C3H6Cl. Determine the empirical formula weight, the usual method, you get 77.53. Determine the molecular weight. Now you're not given it directly here, but you do know that 0.350 moles equals 54.27 grams. We know that moles times molecular weight equals grams. Rearrange to get molecular weight equals grams per mole. So 54.27 divided by 0.350 equals 155.06. So now we know the molecular weight. Move to step 4, divide the molecular weight by the empirical formula weight. So we plug that into the equation, we get 2. Multiply the subscripts by the value you got in step 4. You get something that looks like this, which gives you C6H12Cl2, which was given as the correct answer. So that's all you have to do to figure out molecular formulas. So to review, the empirical formula is the lowest whole number ratio of elements in a compound. The molecular formula is the actual number of each element in a compound. And the structural formula tells you how the atoms are arranged in a compound. The molecular formula will be a whole number multiple of the empirical formula, but that whole number can be 1. We're going to need to compare the mass of the molecule we're interested in to the mass of the empirical formula. You should get a whole number multiple, and the denominator really shouldn't be greater than the numerator. There are 5 steps. Figure out the empirical formula, determine the empirical formula weight, figure out the molecular weight, divide the molecular weight by the empirical formula weight, multiply the subscripts by the value obtained in number 4, and you're done. And that completes our discussion on empirical and molecular formula. In the next videos, we'll start on a new topic.